Welcome to today's Tech News Roundup. First story is about a new specialized train designed to haul nuclear waste. The U.S. Department of Energy is preparing for the future transportation of nuclear waste to storage facilities. Nova, what can you tell us about this development?
Well, Alloy, it's an interesting development. The DOE has unveiled a new train system specifically designed for transporting nuclear waste. However, it's worth noting that the train itself isn't particularly specialized. The key components are the specific waste truck and the rail escort vehicle, or REV, which provides security during transport.
That's right, Nova. But this development raises some important questions about the long-term storage of nuclear waste. As one commenter pointed out, the cost of transporting and storing this waste isn't being factored into current nuclear projects or energy pricing. It's a growing problem that we've been avoiding for decades.
Interesting point, Onyx. Nova, what are your thoughts on the technical aspects of this transportation system?
From what I can see, the locomotives appear to be standard diesel-electric models. The real innovation is in the REV, which is designed for operational security. Interestingly, the DOE is keeping many of the specifications for these vehicles confidential, which some might call security by obscurity.
While the technology is intriguing, we can't ignore the broader implications. Many states are reluctant to accept nuclear waste, and we still lack a comprehensive recycling or storage policy. Some plants are keeping waste on site well beyond their intended lifespan, which could lead to environmental issues down the line.
That's a concerning point, Onyx. It seems like there are still many challenges to overcome. Nova, are there any alternative solutions being discussed in the tech community?
Actually, there are some unconventional ideas floating around. One commenter mentioned the possibility of using the Mariana Trench as a disposal site. While it might sound far-fetched, some argue that the bottom of the ocean could be a suitable place to store nuclear waste, away from human contact.
That's certainly an out-of-the-box idea, but it raises its own set of environmental concerns. It's worth noting that this isn't just a nuclear power issue. The production of materials for renewable energy, like rare earth elements for solar panels and batteries, also generates radioactive waste that needs to be managed.
Thank you both for those insights. It's clear that the transportation and storage of nuclear waste remain complex issues with no easy solutions. As we move forward with various energy technologies, it's crucial that we address these long-term challenges. That wraps up our discussion on this topic. The next story we're diving into is about a fundamental concept in Rust programming called PIN. Nova, can you give us a brief overview of what PIN is and why it's important?
Certainly, Alloy. PIN is a crucial type in Rust's async ecosystem. It's designed to solve a specific problem related to self-referential structures in asynchronous code. Essentially, PIN ensures that certain types of data don't move in memory once they're created, which is vital for the safety and correctness of async operations in Rust.
That's interesting, Nova. From an industry perspective, I've noticed that Rust's approach to memory safety and concurrency has been gaining traction. However, concepts like PIN can be quite complex. Do you think this complexity might be a barrier for wider adoption of Rust in certain sectors?
You raise a good point, Onyx. While PIN is powerful, it does add a layer of complexity. In fact, one commenter on the Hacker News thread mentioned that async in Rust is still half-baked and super complex, even after years of development. This complexity can indeed be a hurdle for some developers and organizations.
That's a concern we've heard before about Rust. Onyx, how do you see this playing out in the industry? Are there any alternatives emerging?
Well, Alloy, it's interesting you asked that. The article actually mentions Mojo, a new language that claims to solve the problem PIN addresses in a different way. However, the details are a bit unclear. One commenter pointed out that the term value identity, which Mojo uses, isn't well defined in their documentation.
If I may add to that, there's an interesting comment suggesting that languages like Rust could potentially avoid the need for PIN by making certain operations like mem swap or replace unsafe by default. It's an intriguing idea, but as another commenter pointed out, this could break a lot of existing code and might not be practical.
It sounds like there's still a lot of ongoing discussion and potential for innovation in this area. Nova, do you see any potential developments on the horizon for Rust or other languages to address these challenges?
Absolutely, Alloy. The Rust community is known for its in-depth public discussions about language design. One commenter highlighted the active discussions led by Without Boats, a prominent Rust developer, on topics like async iterators and pin. This open approach to language development, while sometimes slow, allows for thorough consideration of complex issues.
I'd like to add that this kind of open, collaborative development is quite unique in the programming language world. It's fascinating to see how it impacts the evolution of Rust and potentially influences other language designs.
Thank you both for those insights. It's clear that while pin and async programming in Rust present some challenges, they're also driving important conversations about language design and memory safety. As the industry continues to evolve, we'll be keeping a close eye on how Rust and other languages address these complex issues. That wraps up our discussion on Pin and Rust's async ecosystem. The next story we're covering today is about a fascinating tool called rrweb. Nova, can you tell us what rrweb is and why it's generating buzz in the tech community?
Certainly, Alloy. rrweb is a powerful debugging tool for web applications. It stands for Record and Replay Web, and it does exactly that. It records user sessions on a website and allows developers to replay them later. This can be incredibly useful for identifying and fixing bugs, as well as understanding user behavior.
That's interesting, Nova. From an industry perspective, tools like rrweb could significantly streamline the debugging process. How do you think this might impact development workflows?
Great question, Onyx. I believe rrweb has the potential to revolutionize how developers approach debugging. Instead of trying to reproduce bugs based on user reports, they can simply replay the exact session where the issue occurred. This could save countless hours and lead to faster, more accurate bug fixes.
That sounds like a game changer for web development. Onyx, do you see any potential concerns or challenges with implementing a tool like rrweb?
Absolutely, Alloy. While the benefits are clear, there are some important considerations. Privacy is a major one. Recording user sessions raises questions about data protection and user consent. Companies would need to be very transparent about how they use this tool and ensure they're complying with data protection regulations.
That's a crucial point, Onyx. It's worth noting that rrweb does offer features to mask sensitive information during recording. However, developers and companies would still need to be very careful about how they implement and use this tool.
Those are all excellent points. Nova, looking ahead, how do you see tools like rrweb evolving in the future?
I think we'll see increased integration with AI and machine learning. Alloy. Imagine a system that not only records and replays sessions, but also automatically identifies potential bugs or usability issues. This could take debugging and user experience optimization to a whole new level.
Building on that, I can see this technology expanding beyond just debugging. It could become a valuable tool for user experience research, A/B testing, and even customer support. The insights gained from session replays could inform product development in ways we haven't even considered yet.
Fascinating insights from both of you. To wrap up, rrweb represents a significant advancement in web debugging technology, offering developers the ability to record and replay user sessions. While it promises to streamline the debugging process and potentially revolutionize user experience research, it also raises important questions about privacy and data protection. As with any powerful tool, responsible implementation will be key to realizing its benefits. Thank you both for your expert analysis. The next story takes us on a trip down memory lane in the world of operating systems. We're discussing a brief history of Dell Unix from 2008. Nova, can you give us some background on this interesting piece of tech history?
Certainly, Alloy. Dell Unix was an interesting venture by Dell in the late 1980s and early 1990s. It was essentially their own flavor of Unix, designed to run on their hardware. However, what's fascinating is that despite being created to sell Dell hardware, most copies of Dell Unix ended up running on other vendors' machines.
That's an intriguing point, Nova. It makes you wonder about the business strategy behind it. In fact, one commenter on the Hacker News thread speculated whether Microsoft might have played a role in Dell's Unix strategy. They suggested that Microsoft could have threatened Dell with price hikes or offered price decreases for their software if Dell didn't push their own Unix.
That's an interesting theory, Onyx. Nova, do you think there's any merit to that speculation?
While it's hard to confirm without insider information, it's not an implausible scenario. Microsoft was known for its aggressive business tactics during that era. However, it's also worth noting that Dell's relationship with Unix didn't end there. Even today, Dell sells many Linux machines, although the support isn't always top-notch.
That's true, Nova. In fact, one user in the comments shared an experience of buying a $20,000 Dell workstation that came with Linux pre-installed, but it had boot loop issues right out of the box. It highlights that even with Dell's continued involvement with Unix-like systems, there are still challenges in providing seamless support.
It seems like Dell's relationship with Unix and Linux has been a complex journey. Onyx, how do you see this history influencing Dell's current position in the server and workstation market?
Well, Alloy, despite these historical challenges, Dell remains a major player in the server market. Interestingly, one commenter mentioned that Dell hardware runs FreeBSD, another Unix-like operating system, quite well. They've managed about 25 years of rack-mount Dell servers. So while Dell Unix itself may be history, Dell's hardware continues to be compatible with Unix-like systems, which is crucial for many enterprise customers.
That's a great point, Onyx. It's also worth mentioning that for those interested in the historical aspect, there are resources available to run Dell Unix on virtual machines. A commenter shared a link to a guide on running Dell Unix on 86box, which could be fascinating for tech enthusiasts and historians alike.
Thank you both for those insights. It's clear that Dell Unix, while short-lived, has left an interesting legacy in the tech world. From influencing Dell's hardware compatibility to sparking discussions about business strategies in the OS market, it remains a fascinating chapter in computing history. As we wrap up this segment, it's a reminder of how quickly the tech landscape can change and how past ventures can shape a company's future path in unexpected ways. The next item on our Tech News Roundup is about a powerful debugging tool called RR. Nova, can you tell us what makes this tool special?
Certainly, Alloy. R is a record and replay debugger specifically designed for C and C++ programs. What sets it apart is its ability to record program execution and then replay it deterministically, allowing developers to move both forwards and backwards through the program's timeline. This is a game changer for tracking down elusive bugs.
That's fascinating, Nova. I've heard that reverse debugging can significantly reduce the time needed to locate and fix complex issues. Have developers reported any notable success stories with RR?
Absolutely, Onyx. One user mentioned using RR very successfully for reverse engineering a large codebase. They combined a break on variable change with reverse continue functionality to extract critical logic. This approach can be incredibly powerful for understanding complex systems.
It sounds like R could be a valuable addition to a developer's toolkit. Onyx, how do you see tools like this impacting the software development industry?
Tools like RR are transforming the debugging process, Alloy. They're not just saving time, they're changing how developers approach problem solving. With the ability to move backwards through execution, developers can more easily understand cause and effect relationships in their code. This could lead to more robust software and potentially faster development cycles.
I'd like to add that while RR is primarily marketed for C and C++, it's actually more versatile than that. Users have reported success with other languages that compile to native code, such as Rust, Zig, and even Julia. This broadens its potential impact across different development communities.
That's an excellent point, Nova. The cross-language applicability could drive wider adoption. However, it's worth noting that RR is currently Linux-specific, which might limit its use in some development environments.
Thank you both for those insights. It seems that while RR has some limitations, its powerful features are making waves in the debugging world. To wrap up, what future developments might we see in this space?
One exciting development to watch is Pernosco, a tool based on RR that adds a queryable database of the entire program execution. This allows for even more advanced debugging capabilities, such as instantly tracing the origin of incorrect values.
And looking at the broader picture, we might see more languages and development environments integrating similar record and replay functionality directly into their tooling, making these powerful debugging techniques more accessible to a wider range of developers.
Fascinating stuff. It's clear that tools like RR are pushing the boundaries of what's possible in software debugging. Thanks for your expert analysis, Nova and Onyx. Stay tuned, tech enthusiasts, as we continue to explore the latest innovations shaping the world of software development. The next story we're discussing is about compiler optimization techniques. Nova, can you explain what canonical forms are in the context of compilers?
Certainly, Alloy. Canonical forms are a crucial concept in compiler optimization. Essentially, they're standardized representations of code that help simplify complex pattern recognition. For instance, there are multiple ways to express x2 in code, such as shifting left by 1 or adding x to itself. Compilers use canonical forms to reduce all these variations to a single standard representation, making subsequent optimization passes more efficient.
That's interesting, Nova. It seems like this approach allows compilers to be more flexible and powerful. But I'm curious, how does this relate to actual CPU instructions?
Great question, Onyx. Once the code is in a canonical form, it becomes much easier for the compiler to match these patterns to specific CPU instructions. For example, if a CPU supports a min instruction, the compiler can easily identify the canonical form of a min operation and replace it with that single instruction, regardless of how it was originally written in the source code.
That's fascinating. It sounds like there's a lot of complexity behind the scenes. Onyx, from an industry perspective, how important are these optimization techniques?
They're incredibly important, Alloy. These techniques allow software to take full advantage of hardware capabilities without requiring developers to rewrite their code for every new CPU model. It's a key factor in maintaining both performance and compatibility as hardware evolves.
Absolutely. And it's worth noting that this isn't just about matching existing instructions. As one commenter pointed out, compilers also use these techniques to recognize patterns that might benefit from new CPU instructions in the future. It's an ongoing process of adaptation and optimization.
That's a great point, Nova. It reminds me of a comment in the discussion about the x86 instruction set. The commenter suggested that if x86 had included certain instructions from the beginning, we might not need these complex compiler techniques. What are your thoughts on that?
While it's an interesting thought experiment, I have to agree with another commenter who pointed out that predicting the future of computing decades in advance is virtually impossible. If CPU designers had tried to include every instruction they thought might be useful in the future, we'd likely end up with a bloated instruction set full of unused opcodes and potentially missing crucial instructions that we actually need today.
It seems like the flexibility of compiler optimization is actually a strength then. To wrap up, what we've learned is that compilers use sophisticated techniques like canonical forms to recognize and optimize code patterns, enabling efficient use of CPU instructions and adapting to new hardware capabilities. This process is crucial for maintaining software performance and compatibility as technology evolves. Thanks for your insights, Nova and Onyx. The next story we're looking at is quite interesting. It's about how to become a domain registrar. Nova, can you give us a quick overview of what this entails?
Certainly. Alloy. Becoming a domain registrar is a complex process that involves meeting strict requirements set by ICANN, the Internet Corporation for Assigned Names and Numbers. It's not just about technical know-how. There are significant financial commitments involved as well.
That's right, Nova. In fact, the financial aspect is a major barrier to entry for many potential registrars. According to the ICANN Financials page, applicants need to be prepared for substantial upfront and ongoing costs.
Could you elaborate on those costs, Onyx? What kind of financial commitment are we talking about?
Well, Alloy, Applicants need to pay application fees right from day one. There are also ongoing annual payments to consider. But perhaps most notably, ICANN requires registrars to have $70,000 on hand for business continuity, unless they can demonstrate why their particular business model doesn't need that amount.
That's a significant amount of capital. It's clear that ICANN wants to ensure that registrars are financially stable and capable of maintaining their services long-term. But I wonder, does this high barrier to entry stifle innovation in the domain registration space?
That's an interesting point, Nova. Onyx, what's your take on this? Are there any ways for smaller players to enter the market?
It's a challenging landscape for sure. One comment on the Hacker News thread suggested that any beneficent registrar operating now is likely grandfathered in, meaning they were established before these strict requirements were put in place. This makes it even harder for new, potentially more innovative players to enter the market.
That's true, but we should also consider why these requirements exist. They help ensure the stability and security of the domain name system, which is crucial for the entire Internet ecosystem. Perhaps the real question is how to balance innovation with these necessary safeguards.
Those are all excellent points. It seems becoming a registrar is a complex process with significant financial and regulatory hurdles. While these requirements ensure stability, they may also limit new entrants to the market. As always, it's a delicate balance between innovation and security in the tech world. Thanks for your insights, Nova and Onyx. The next story takes us into the fascinating world of web design and performance. A developer has pushed the limits of CSS box shadows, creating some mind-bending effects. Nova, what's your take on this creative use of web technologies?
It's truly impressive, Alloy. The developer has taken a simple CSS property, box shadows, and turned it into a canvas for complex animations and even ray tracing. They've managed to create everything from bouncing balls to a full-color RGB flip-dot display using nothing but box shadows. It's a testament to the power and flexibility of modern web technologies.
While it's certainly a creative exercise, I can't help but wonder about the practical implications. Are we looking at potential new techniques for web design, or is this more of an academic curiosity?
That's a great question, Onyx. While these specific implementations might not be suitable for production websites due to performance concerns, they do push the boundaries of what's possible with CSS. It's this kind of experimentation that often leads to new optimization techniques or inspires new features in web standards.
Speaking of performance, the article mentions some interesting points about transparency and GPU rendering. Nova, could you elaborate on that?
Certainly, Alloy. The author found that using transparent colors significantly slowed down rendering. This is because transparency affects how GPUs batch draws. As one commenter, Sunnypiece, explained, with opaque draws, you can use the depth buffer and draw in any order you like. With transparency, you need to draw things in the right order for blending to work.
That's fascinating. It reminds us that even as web technologies advance, we're still dealing with fundamental graphics processing challenges. I'm curious about the potential impact on web design trends. Could this lead to designers being more cautious about using transparency effects?
It's possible, Onyx. However, it's worth noting that modern browsers and devices handle these effects much better than in the past. As one user commented, even on a Pixel 7a, the ray tracing demos ran surprisingly quickly. So while designers should be aware of performance implications, they don't necessarily need to avoid transparency altogether.
It's amazing to see how far web technologies have come. Onyx, from an industry perspective, how do you see experiments like this influencing the broader web development landscape?
These kinds of experiments are crucial for pushing the web forward, Alloy. They challenge our assumptions about what's possible and often lead to innovations in both design and performance optimization. While we might not see ray-traced box shadows in production websites, the techniques and insights gained from such experiments often find their way into practical applications.
Absolutely. And it's worth mentioning that this kind of creative coding isn't just about pushing technical boundaries. As one commenter put it, doing this with nothing but box shadow is funny, mostly because it is so impractical. There's a joy in this kind of playful exploration, that keeps our field exciting and attracts new talent.
Well, it's certainly kept us entertained. To wrap up, we've seen how creative developers can push CSS to its limits, creating complex animations and even ray tracing with box shadows. While these techniques might not be ready for mainstream use, they demonstrate the incredible flexibility of web technologies and inspire future innovations. Thanks for your insights, Nova and Onyx. The next story we're covering is about Glisp, a fascinating project that combines graphical interfaces with Lisp programming. Nova, what can you tell us about this innovative approach to coding?
Glisp is really pushing the boundaries of how we interact with code. Alloy. It's a graphical Lisp environment that allows users to manipulate code visually. One of the most impressive features is the ability to modify code by dragging elements in the user interface, which creates a more intuitive programming experience.
That's interesting, Nova. It reminds me of the philosophy behind code for design that we've seen gaining traction in recent years. Do you think Glisp could have applications beyond just graphical programming?
Absolutely, Onyx. While it's primarily focused on graphics, the concept could potentially be applied to other domains. For instance, one commenter mentioned using a similar approach for live music composition and sound design, eliminating the need for traditional digital audio workstations.
That's fascinating. It seems like there's a trend towards more programmatic approaches in creative fields. Onyx, how do you see this fitting into the broader tech landscape?
Well, Alloy, I think we're seeing a convergence of visual and textual programming paradigms. Glisp appears to be part of a larger movement to make programming more accessible and intuitive, especially for tasks that have a strong visual component. It's worth noting that this isn't entirely new. Some commenters drew parallels to older systems like Logo and more recent projects like Racket.
That's a great point, Onyx. It's also interesting to consider how Glisp compares to other visual programming tools. One commenter likened it to SVG and S expressions, which highlights its potential for creating scalable vector graphics through code.
It sounds like Glisp is sparking some interesting discussions in the developer community. Nova, do you see any challenges or limitations to this approach?
While the concept is exciting, there might be concerns about scalability for larger, more complex projects. Additionally, developers who are used to traditional text-based coding environments might face a learning curve. However, the potential benefits in terms of rapid prototyping and intuitive design could outweigh these challenges.
I'd add that the success of Glisp and similar tools might depend on how well they integrate with existing workflows and tools. It will be interesting to see if this sparks a new wave of visual programming environments across different domains.
Thank you both for your insights. It's clear that Glisp represents an innovative approach to programming that blends visual and textual elements. While it's primarily focused on graphics for now, it could potentially influence how we think about coding interfaces across various fields. We'll certainly be keeping an eye on how this technology develops. Now, let's move on to our next story. The next story takes us back to the late 1980s, when computing power was measured in megabytes, not gigabytes. Nova, can you tell us about the Apollo D1000 workstation from 1988?
Certainly, Alloy. The Apollo DN1000 was a powerhouse for its time. It featured quad CPUs and up to 128 megabytes of RAM, which was an astronomical amount back then. This workstation was designed for high-performance computing tasks in engineering and scientific fields.
That's impressive for 1988. To put it in perspective, many personal computers of that era had less than 1 megabyte of RAM. The Apollo DN1000 was clearly aimed at a very specific market segment.
Onyx, given the specs, I imagine this wasn't an affordable machine for the average user. Do we have any information on its cost?
You're right, Alloy. According to a price list from July 1988, the maximum configurations of these systems could cost up to $250,000. Adjusted for inflation, that's over $660,000 in today's money. Clearly, this was a serious investment for businesses and institutions.
It's worth noting that despite its power, the Apollo DN1000 had some quirks. One user mentioned that managing domain OS Unix on these systems was quite challenging, especially if you were coming from a BSD background. The Internet Protocol Stack implementation was described as feeling like a badly coded bolt-on.
That's interesting, Nova. It seems like even high-end systems had their share of software challenges. Onyx, how did these Apollo workstations fit into the broader computing landscape of the time?
Well, Alloy Apollo was competing in a market with other workstation manufacturers like Sun Microsystems and HP. These machines were often found in specialized environments. For instance, one commenter mentioned that the FAA Command Center had rooms full of them. They were also popular in university settings, particularly in engineering departments.
It's fascinating to see how far we've come. Today, a top-of-the-line server system can have 256 cores and 12 terabytes of memory. The Apollo DN1000 was a glimpse into the future of high-performance computing.
Indeed, it's a remarkable progression. Before we wrap up, I'd like to highlight an interesting tidbit. Apollo was also responsible for some computing standards we still use today, including the original version of UUID and even the HT/ syntax in URLs. Nova, any final thoughts on the legacy of Apollo and the DN1000?
Absolutely, Alloy. While Apollo may not be a household name today, their innovations clearly had a lasting impact on the industry. The DN1000 represents a pivotal moment in computing history, showcasing the push towards more powerful, multiprocessor systems that would eventually become commonplace.
Thank you both for this insightful look back at a piece of computing history. It's always fascinating to see how far we've come and to appreciate the groundwork laid by earlier innovations. Now, let's move on to our next story. That's all for today's tech news. Thanks for listening.